Hello everybody and welcome to a new video. In this video we will be introducing velocity versus time graphs. In the previous video we talked about displacement versus time graph. I really encourage you to watch the previous video before starting with this video because it will help a lot. So velocity versus time graphs are simply graphs that show the relationship between velocity and time, so it's straightforward. Just like in displacement versus time graphs, in velocity versus time graphs, the time will take the x-axis and the velocity will take the y-axis. Now, these graphs can be in three forms, just like displacement versus time graphs. Okay, so they are somewhat similar, but they are very much different. They kind of look the same, the x-axis is the same, but they are very different from each other, so they need a high level of concentration when studying the difference between these two graphs. So we can have three shapes of graphs. We can have the constant graph, we can have the linear graph, and we can have the non-linear graph. But it's important to know that we will only be dealing with the first two types. We will be dealing with the constant and the linear. Why? I think you will get that by yourself by the end of the video. Why will we not be dealing with the non-linear or the curved graph? While on the displacement versus time graphs, yes, we covered the non-linear graph and what it does. So let's start with the first type. Let's start with the constant graph. As we can see, the time has the x-axis and the velocity has the y-axis, and we have a simple linear line. In this case, we can say that although time is passing by, if we look here, we can see that time is passing by, but I'm still having the same velocity. The velocity is not changing. For example, it's 5 meters per second. So this can only mean that since the velocity is not changing, this means that the acceleration is equal to 0. There is no acceleration in this case. Okay, so if we see a velocity versus time graph and it's a constant graph, we can say that the velocity is constant and the acceleration is equal to 0. Okay, now let's look at the other type of graphs. What if we see a linear graph? What does that indicate? Well, from this graph we can conclude that first of all the object is changing its velocity. Now what's happening is that the velocity is changing, it's increasing every second, it's increasing. Okay, so since we have increasing velocity, this means that there will be acceleration. We mentioned before that the words constant velocity means zero acceleration, and varying or changing velocity means that the acceleration in this case it is not zero. And in our case, since the graph is linear, this means that the acceleration is constant. What does acceleration constant mean? Well, that means that the acceleration is not changing. But keep in mind, constant acceleration does not mean constant velocity. Zero acceleration means constant velocity. I know it's kind of cumbersome at the beginning, but you will get the hang of it. Okay, now the most important piece of information, or two pieces of information, one of them is that if I find the slope of this line, I will find the value of the acceleration. We know that the slope is equal to the change in the y-axis divided by the change in the x-axis. So what does the y-axis represent? It represents velocity, so it's the change in velocity divided by the change in time, because the x-axis shows us time. Now change in velocity divided by change of time will give me acceleration, and we already introduced that before, so we just proved that the slope is equal to the acceleration. Now one of the most important things when we are dealing with velocity versus time graphs, and this does not work with displacement versus time graphs, it only works with velocity versus time graphs, is that the area under the velocity versus time graph can be used to measure the displacement the object travels. So we have a velocity versus time graph. It doesn't mention the displacement. How can I find the displacement? By finding the area of this shaded shape right here, I am finding the displacement. Okay, again, if I have a velocity versus time graph, first of all, I know that the slope will give me the acceleration, and the area below the curve will give me the displacement. Okay, now again, it's the area below the curve right here, not this one. This one is not correct. Okay, we will be dealing with the area below the curve. Okay, so in this case, since we have a triangle, if I find the area of the triangle, as a quick reminder, the area of a triangle is equal to half multiplied by base multiplied by height. If I find this area, I will have the displacement. Okay, now let's look at a quick example on finding the displacement. We have the following shape. It's a triangle, as you can see. we have the following values. The velocity is equal to 8 right here, and the time starts from 0 and ends up at 10. If I want to find the displacement, as the question is asking me to find, it's asking me to find the displacement. Well, I can say that the displacement, which is delta D, is the area of a triangle, which is equal to half multiplied by base multiplied by height, which is equal to half multiplied by 10 multiplied by 8, and this gives me a displacement equal to 40 meters. Okay, again, the unit here is meters, but we just found the area. It doesn't have to be meters square. Well, yes, we are finding the area, but the area here, it's representing the displacement, so the unit will be meters. Another quick example, if we look at this shape right here, and we were asked to find the displacement, here's the velocity versus time graph. As you can see, it's going up and down. So the area here is equal to the displacement, which is equal to half multiplied by base, which is 8 multiplied by the base. What's the base in this case? Well, some of you may just quickly type in the number 10, but as you can see that the base here, it's going to be 10 minus 5 because it's not the whole distance, so it's only 5. So half multiplied by 8 multiplied by 5, you can use the calculator and find the value. Let's look at another shape. Okay, now let's look at this shape. Here we have another triangle. We are trying to find this area right here. Okay, so it's straightforward, half multiplied by base multiplied by height. It's easy and straightforward. The next one, let's look at this shape. Okay, now we have more than one shape. Some of you might look at it as a trapezoidal shape. Some of you may think of it as a triangle right here, and here we have a rectangle, and here we have another triangle. So if we use the equation to find the trapezoid, we can say that the displacement is the area of a trapezoid, which is equal to half multiplied by the base, or the first base, plus the second base multiplied by the height. So in our case, we can just say it's equal to half multiplied by the first base. Where's the first base of the trapezoid? It's this one, okay? So it's equal to 20 plus the other base. It's this one right here. It's equal to 15 minus 5, which is equal to 10, multiplied by the height. The height is from here to here, which is equal to 7. So this is the first way of finding the displacement. Some of you may think of it as a triangle, a rectangle, and a triangle. So we can say that the displacement is the area of the first shape plus the area of the second shape and the area of the third shape. The area of the first shape is equal to half multiplied by the base, which is equal to base from here to here, which is equal to 5 multiplied by the height, which is equal to 7, plus the second area here. It's a rectangle. The rectangle has an area equal to base multiplied by height. For a rectangle, the area is equal to base multiplied by height. So the base in our case is equal to the distance from here to here, which is 10, multiplied by the height, which is 7. And finally, the third triangle has the area of half multiplied by base. The base is from 15 to 20, so it's only 5 multiplied by the height, which is 7. In both cases, we will get the same displacement, and the unit is meters. Okay? For the next shape, okay, we have a triangle and we have a rectangle right here. So we can call this area 1 and we can call this area 2. For area 1, it's a triangle, so it's half multiplied by base, which is 5. It's very clear. Multiplied by the height, which is 5. And for the second area, it's equal to the base multiplied by the height. Now the base is from here to here, so it's only 2 multiplied by the height. So the displacement will be equal to the first area plus the second area. Okay? We can just plug in the numbers and we will get the final answer. Now, this shape, the same idea. The shape only shifted to the right, so it's only a triangle with a rectangle. And the base here is equal to 2. And here the base is equal to 3. And the height is equal here to 10. And here it's also equal to 10. Okay? The height is equal to 10. So no need to solve this one. Now for this shape, it's a little bit complicated, but it's the same concept. I'm just gonna divide it into areas. So we have here a triangle, let's call it 1. We have here a rectangle, let's call it 2. Okay, here we have a rectangle. Now we can divide this into a big rectangle, as shown here, and a small triangle like this. So this will be area 3 and this will be area 4. Small trick here is the height is only 5 and the base is only equal to 15 minus 12, which is equal to 3. So that's the whole idea about velocity versus time graphs. Stay tuned in the next videos. We will be solving problems on both types of graphs. See you then.